Hello everyone. So today we are going to see a new topic, greatest common divisor of two numbers. Alright, so let's brush up about it. So greatest common divisor means the greatest number which divides both of these numbers. Alright, so let's take few examples. Suppose there are two numbers 4 and 6, right? So what would be the greatest number which would divide both of them? It is going to be 2, right? Now let's have another example, 100 and 200. So there would be many common divisors such as 2, 5, 10, etc. Right? But what would be the greatest number? It is going to be 100, right? 100 is going to divide 100 obviously and 200 also, right? And there would be no number greater than 100 which would divide both of them. Okay. Now let's talk about this example 7 and 13. So as you can see that both of these are prime numbers and there would be no greatest common divisor. So only one would exist which would divide both of them. Hence answer is going to be 1. Alright. Now the question arises, how do we compute this through programming? So let's talk about algorithm which we use. So the algorithm which we use here is Euclidean algorithm. Alright. So the basic idea of this algorithm is, suppose we have two numbers A and B, and B is smaller than A. Then we can say that GCD is short form of greatest common divisor. Okay. So GCD of A and B is going to be equal to GCD of A minus B and B. Now you might be wondering how. So we have the proof here. So the proof is, suppose G be the GCD of A and B, right? So we can write A as Gx and B as Gy. And since G is the greatest common divisor, so there would be no common divisor between x and y. Hence GCD of x and y is going to be 1, right? So if we subtract B from A, then what would we get? Gx minus y, right? And what would be the greatest common divisor of, or what would be the multiples of A minus B? So one would be G, right? And one would be x minus y. And if I tell you like what would be the GCD of A and A minus B, since x and y don't have any GCD, the GCD is 1, so they won't have any common divisor. So the only term left is G, right? So G would be the greatest common divisor of A and A minus B, and similarly GCD of B and A minus B is also going to be G, right? So the main idea of the program would be to have this x minus y, or x minus y as 1. So how can we achieve that? So what we are going to do is that unless A is not equal to B, we'll use a loop, and what we're going to do is we'll continuously subtract the smallest number from the biggest number. So that after 2 or 3 loops, A is greater. So we'll subtract B from it, and after that, loop, suppose B becomes greater, then we'll subtract A from it, and this goes on until A becomes equal to B. So suppose there is no common divisor, so 1 would be the answer. So there would be a point when A and B both becomes 1, and that case would also have A is equal to B, and so we'll come out of the loop, and then we can return either A or B. Okay. Now here I have one example, 12 and 15 as A and B, and let's try doing a dry run here. So we'll use a while loop to compute the GCD, and we'll use a loop until A becomes equal to B. And inside the loop, what we are going to do, we are going to subtract the bigger number from the smallest number. Alright. So now B B is greater here, so A minus B becomes what? B minus A becomes, B now becomes 3, right? And what does A become now? It is still remains 12. Now after this pass, A becomes greater than B. So what we are going to do is we are subtracting B from A. Hence value of A becomes 9, right? And B still remains 3. Alright, now after this loop, A is still greater than B, then we'll again subtract B from A. So now A becomes 9 minus 6, which is equal to 9 minus 3, which is equal to 6. And B still remains 3. Now we see A is again greater than B, then we'll again subtract B from A. Then A is going to be 3 and B is going to be 3. Now this is our condition of while loop, right? A is equal to B. Hence we'll come out of the loop and we'll print either one or either of them, right? Hence this is the way how we can find GCD. Also you can check that GCD of 12 and 15, since these are small numbers, you can check GCD for yourself. Hence it is going to be 3, right? Now let's try to do the coding part here. So let's first include the header file here. Yeah. All right. Now let's have our main function. We will have two variables. Let's have them A and B. All right. And let's have them as user input. All right. And then what we are going to do is we are going to simply see out GCD A and B. All right. Let's have a function GCD where we will declare two variables, int A and int B. All right. Now what would be the, now there is going to be a while loop, right? So let's have a while loop. So what would be the condition? That A not equal to B, the loop would run till then, right? Now what we are going to do is we'll check if A is greater than B. Then what we are going to do is subtract B from A, right? Else B would be greater than A. Then we are going to subtract A from B, right? Now we are going to return A. You can also return B because both are going to be same, right? Hence this would be the code. Okay. Now let's try and run it. Let's have the, let's have A as 12 and B as 15. Okay. Let's see. Let's have A as 12 and B as 15. Hence output is 3. GCD is 3 here, right? Now let's have another example of 100 and 200. Alright. Okay, so 100 and 200. See, GCD is 100, which we saw in our example. Alright. Now from GCD, from Euclidean algorithm, you can also find LCM. right? I must be wondering how. Alright, so recall that you have read a formula somewhere, that is multiplication of two numbers is equal to GCD cross LCM, right? Now what is LCM? LCM is least common multiple, meaning the least number which is multiple of both of the numbers, alright? So if you have to find the LCM here, what you have to simply do, you have to find n1 into n2, which you can easily find, right? And then you have to find GCD through the above Euclidean algorithm, right? We also saw the coding part of how we have to do it. And then you just simply divide the product of both the numbers by um, GCD, alright? And that's how you find the LCM. Okay, so I hope Euclidean algorithm and how to find GCD through it is clear to you, and you also got to know how to find the LCM. Alright, so that's it for this video, and see you later.